Hey everyone, in this video we're going to learn about the 5 main building techniques used to design a super energy efficient passive house. Passive house is a building standard that's used to design and build homes to be more energy efficient than a conventional building. They do this by adding extra insulation in the walls, creating a sealed layer around the building, and preventing any heat from escaping, and a whole lot more. We're here at BCIT's High Performance Building Lab, which is a new hands-on learning space that was created to train BC tradespeople on green building techniques. We're about to meet up with Sandra and Alex, who are 2 brilliant people who are also very passionate and well-educated in green buildings, and they're going to tell us how all this works.
The passive house standard actually can reduce your energy consumption for heating demand by up to 90%. It's that much. So think about what you get, right? You get an extremely healthy building. Yeah, that's usually the part that people don't really, you can't put that into monetary value, but you do get a very healthy, comfortable building that has impact on your physical health, but also on your mental health. The other one is obviously your return of investment on your energy savings. So really, again, depending on where you are and what your energy costs are, it's a no-brainer. The costs that you obviously have upfront that you can't deny is you have more insulation, you have better performing windows. But in terms of labor, the upfront premium would be somewhere in between 3 to 10%, depending on where you are. Yeah, more than conventional construction.
I believe climate change is real, and I really think we should do something about it. And it's the first time that I've seen something that I think can make a huge difference. It's also the first time that I've seen something that I understand. Everything else is so complex that unless you have the perfect storm, it will not work. And I've seen that again and again and again in the buildings I've worked in the last 8 years. So what gets me really excited about this is that passive house is simple.
When we talk about a building envelope, that basically means the walls, the roof, the floor, the doors, and the windows, right? So everything that kind of encloses the building area volume is called the building envelope. When it comes to the wall, in general, we have 5 layers that are really important in any kind of wall assembly, not only passive house walls. We see several assemblies that you can use in passive house construction. This one shows the water shedding layer here. Then this wood fiber board is the water resistive barrier. Then you see some blown in cellulose fill in here between some normal 2x10 wood studs. The air barrier on this one is actually this wood fiber board taped. So when you tape the wood fiber board, it can become your air barrier. And then you can see here is an OSB layer. That's oriented strand board. If this is taped, it's actually in this case your vapor retarder. And then in this wall assembly we have what they call a service cavity. So that's another 2x4 layer, also filled with the insulation. Not here, but in reality. The service layer makes a lot of sense to have because then you don't have to penetrate your vapor retarder anymore when you kind of do your installations. So this is a really recommended wall assembly. You see that the wall is fairly thick, yeah? So this is part of the passive house concept where we focus on the envelope first, passive part of buildings, yeah? So we have a super thick insulation. So one thing I hear a lot and I want to shed some light on is that a lot of people think, I'm gonna build an airtight house, I'm gonna sit in a plastic bag, and it's terrifying. That's exactly what I thought when I built my first passive house for myself. I thought I'm gonna sit in a plastic bag. Plus they think you can't open the windows, yeah? So there's 2 things in there that are actually false. You can always open your windows, you just don't have to, and you shouldn't during the heating period. And you will not find the need once you live in it, because you have the heat recovery ventilation system. But when it comes to the airtightness and your wall assembly and air barrier, don't think of it as a plastic bag, think of it as Gore-Tex. Yeah? You're actually creating a breathable wall assembly. the envelope gets to that point and it gets so good that we actually lose our heating system. We don't have a conventional heating system in a passive house. All we have is our heat recovery ventilation system plus a minimum of heat supply somewhere, 15 kilowatt hours per square meter per year. For a normal single family house, you could achieve that with a hairdryer. One baseboard heater somewhere in your house is sufficient for heating. So we want to control the airflow in a passive house building envelope to control heat energy loss, to control unwanted heat gain, and to control infiltration of pollutants. And therefore, we actually do need a continuous air barrier around the building. In here, there is different membranes most likely, and then to connect all these pieces, we usually use high-performing tapes. We do airtightness testing with this equipment. This is called the blower door test. In simple terms, what it is a pressurization and depressurization test of the entire building. And you take one opening, in this case it's a door, we took out the door, to install the equipment, and it comes with a fan and it comes with a pressure gauge. So you can put in all your settings. You put in the area of the building, you put in the volume of the building, and then when you pressurize your building, you pretty much blow air into the building. And then to find leaks, if your blower door test doesn't come out to 0.6 or better, you just go around the seams. Yeah, you could sometimes you can feel it behind the seams. Or the first thing you usually check is you go around the windows, and sometimes you can feel the leaks. It's easier to detect the leaks just by hand on the inside. When it's cold outside, warmer inside, it's easier to feel. Sometimes you can use smoke machines to detect leaks. That works quite well. If you do so, inform your fire department before. And they come, because it can be big. In simple terms, what a thermal bridge does, it actually creates a pathway for the energy and the heat, which is the energy, to travel through the envelope from the inside to the outside. It's a continuous path for energy to go out of the building. So we heat our buildings and right away it keeps on going out. So it's a huge factor for heat loss. So to deal with the thermal bridging effect of the actual studs in the wall assembly, whenever you have two layers of insulation and not one big fat wall, like here we have the main layer and then we have the surface cavity, if you do it right, the actual stud that's within this wall assembly and the stud that is used for the surface cavity, they are offset. Yeah? So you don't have that continuous thermal bridge, but it's offset, so it's interrupted and it's not a thermal bridge anymore. Ventilation has to happen for various reasons. Three of the major ones would be smells, air pollutants, and humidity. And humidity for occupant comfort, and the other one would be protecting the structure from moisture. In a passive house, we use a ventilation system with heat recovery ventilation. So we typically use an HRV system, which means we use controlled ventilation. So we don't just randomly open our windows, which pretty much means heat loss, uncontrolled heat loss. But we have an HRV unit that has very low energy consumption to run the fans, and it has to have 75% heat recovery ventilation rate as a minimum. So this is a very common heat recovery ventilation unit. So the way these heat recovery ventilation units work is to have a cross-flow heat exchanger. This is the actual core, yeah, this is the actual heat exchanger. It's as simple as that, yeah. Supplier comes in here, extractor comes in there, and in this core, the energy gets exchanged. So this is pretty much the entire mechanical system that you will find in your house. It's if it's a house, yeah, obviously bigger ones we have bigger ones for multi-residential buildings or for commercial buildings. When you think about windows, have you ever thought about how incredible windows actually are? In terms of all the functions they actually fulfill, which is pretty much everything a normal wall assembly fulfills, which is mainly It's a water shedding surface, it's a water resistive barrier, it's an air barrier, it's a vapor barrier, and it's insulating. So all that in one piece of element. Plus, the window is also the only element in our wall assembly that's not only about heat loss, but also for heat gain. Yeah? So it's a fairly involved piece of equipment, really. Orientation of the window with the right performance and the right size is really important. So south windows are the best on our side of the earth. East and west not that great, because the sun's really low and goes into the building really deep. So that has a big overheating potential. North-facing windows obviously are not really about heat gain. They're all about heat loss because we don't have sun in the north. The window frame is the weakest part in our entire building envelope in terms of heat loss. Yeah, which is why in passive house construction, we tend to over-insulate the frame as much as we can.
Thanks for watching this video. We hope you enjoyed learning more about these green building techniques with us. We'll put a link to the BCIT High Performance Building Lab in the description of this video if you want to find out more about what's happening here.